Hello everyone! In this guide, I'm going to show you how to recreate some of the puzzles you may know from Genshin Impact inside Miliastra Wonderland. I'll walk you through everything step by step, and I'll also share all the assets used in this video, as well as the GUID of this tutorial stage, so you can load it up and see how everything works for yourself. Now, let me show you what I've prepared. First, we have a Seelie. Once we get close to it, it flies to the next position and repeats this a few times until it reaches its destination. After that, an openable chest spawns nearby for us to loot. Next, we have a cube device puzzle from Inazuma. The goal is to rotate all of the cubes so that they all face the same direction. When we attack the leftmost cube, it rotates 90 degrees clockwise. Attacking other cubes also causes all adjacent cubes to rotate 90 degrees clockwise. After we solve the puzzle, a chest spawns along with some fireworks. I will now show you how to create this puzzle step by step in Miliastra Wonderland. Before we talk about the puzzles themselves, I've prepared some assets with prefabs of this whole scene, so you can easily download them and place them on your stage. Let me show you how to do that. First, head to the link in the video description and click Download Resources. To start creating your stage, open Genshin's in-game menu and look for the lobby under Miliastra Wonderland. Join the recommended lobby or click Go to Public Lobby at the bottom. Then click the first button in the upper right icon list and select Create New Save. To use my assets, you have to choose Classic mode here. This lets you play as your favorite characters from Genshin Impact. Then go to the main menu by clicking the button in the upper left corner and find the Manage Asset Import Export tab. Click it, and in the first tab, called Import and Transfer, click Load External Assets. Next, click Open Directory and move your downloaded file into this folder. After that, click Load External Assets. Now, select the file called Scenery for my guide and click Transfer Selected Assets. In the Transfer Asset window, choose whatever option you prefer. Personally, I like my imported assets to be in the Import Assets tab. After selecting your preference, click Confirm to complete the transfer. Your newly downloaded assets are now in the third tab at the top, called Prefab Library, and in the fourth tab on the left, called Prefab Group. You should now see 3 prefab groups in your Import Asset tab. Simply drag them onto your stage to see them. You can move, rotate and edit them however you want. You can also place them directly in the Entity Placement tab by finding them in the Prefab group under Import Assets. That's what you should do now if you want to replicate the stage from this guide. To add this little pool of water under the bridge, you need to head to the first tab called Terrain Editing and select Area 1 brush on the left. Then click on the little water icon on the bottom and left-click any terrain you want to turn into water. If you made any mistakes, you can undo your actions by using Ctrl+Z command, or by selecting Delete at the bottom and selecting the water tile you want to turn into normal terrain again. After you're done, exit the Draw Terrain window by clicking on the X in the upper right corner and switch to the Entity Placement tab again. Now it's time to create some puzzles. Let's start with creating a Seelie. We need an object that follows a preset path and only moves to the next waypoint when the player gets close to it. At the end, it should trigger some kind of reward, like a chest, fireworks, or anything else you prefer. To start, go to the third tab at the top called Prefab Library. This is where we will create all our prefab models that we can use later in the Entity Placement tab. For the Seelie, look for an empty model on the left and tweak its appearance using Visual Effects or VFX. First, disable its native collision by unchecking Initially Effective and leave the other options in the first tab unchanged. In the third tab, we need to add some components by clicking the Add Common Component button at the bottom. Our Seelie needs a collision trigger, so it moves when the player gets close, a basic motion device, so it can move at all, and a collision trigger source, so it can be detected by the Seelie cord at the end. We will tweak these components in a moment, but let's start from the top. Add a custom variable to the Seelie by clicking Advanced Editing under Custom Variable. Its job is to track which waypoint the Seelie should move to next, and we'll use it later in the node graph. Click +Add New Variables, set any name you like, in this guide it's Path Waypoint, change its type to integer, and set its value to 1. Next, add some VFX so the Seelie is visible at all by clicking Advanced Editing under the VFX Playing tab. Change VFX asset type to Looping Effects and select one or more VFX. For example, Cyan Surrounding Light Effect and Cyan Vortex. Set an offset of 0.5 on the Y-axis so they appear slightly above the ground. You can preview how your VFX combination looks by clicking Preview Combination at the bottom and selecting all your chosen VFX. Next, click Advanced Editing under Collision Trigger and click on plus. Set it to Initially Effective and set Effective Target to only characters, since only players should trigger the Seelie's movement. Then choose a trigger area shape and radius. This is the area that player must enter to trigger the Seelie. For example, choose a sphere with a radius of 2.5. Next, click Advanced Editing under Basic Motion Device and click plus. Do not set it to Initially Effective, because we'll control the movement on demand with node graphs. Change the motion type to Fixed Point Motion. These options will be overridden by node graphs, but for clarity, change movement type to Uniform Linear Motion, arrival method to Fixed Speed, and velocity to 3 meters per second. This motion's name will be used later in node graphs, so remember it. In this guide, it's named Seelie Motion. Finally, tweak the collision trigger source. Go to Advanced Editing under Collision Trigger Source and set it to Initially Effective. Again, set a trigger area, but this one can be smaller since only the Seelie cord will use it, not the player. Now, we'll create the final destination for the Seelie. Look for something that looks like a Seelie cord, for example a wooden mechanism model. Add a single component, collision trigger. You can add it via the Add Common Component button. Set it to Initially Effective, set Effective Target to only objects, and then set a trigger area, for example a sphere with a radius of 1. and tweak the Y-axis of the center so the trigger area sits slightly above the ground. Next, we need a reward. Here, it will be an openable chest with a visible pile of Mora inside. Look for precious chest in dynamic units and Mora pile in static units landform. On the first tab for the chest, you'll notice an option called Preset Status. When this is set to 0, the chest is closed. When set to 1, the chest is open. We will use that later in the node graph. What matters right now is going into Create settings at the bottom and unchecking Initial Create for both the chest and the Mora pile, since they should only appear once the Seelie reaches the cord. We also need to add one component to the chest called Tab, which lets us interact with the chest when we're near it. Click Advanced Editing under Tab and set it to Initially Effective. Name the interaction option Open and leave the rest of the settings unchanged. Optionally, tweak the trigger option area so you can interact with the chest from farther away. For example, set the zoom multipliers there to 3. Next, we need to create a path. Go to the main menu via the upper left button and click on Path Management. Note that this can't be used while you're in the prefab library, so switch to the Entity Placement tab first. Create a new path by clicking the Create Path button at the bottom. You will see an arrow pointing in some direction. You can change this direction freely, and then click Add Waypoint to add the next stopping point for your Seelie. You can adjust the direction and length of every segment, but make sure the last waypoint is placed on your Seelie cord. Each path has a unique index that can be referenced in node graphs, so remember where to find it. The last step for a fully functional Seelie is to create a few node graphs. These are set up in the Miliastra sandbox, also called the Beyond editor. This tool is always open in the background when you create stages in Miliastra Wonderland. Before we create node graphs for our Seelie, let's go over some basics now. You can place nodes by right-clicking on an empty space. Node graphs are basically visual scripts. Instead of writing code, you connect little blocks together to tell the game what to do. Each block is called a node, and each node has one specific job. For example, when this object is attacked, add one to a variable, play a special effect, or destroy this object. Every node graph should start with an event node. That's the thing that wakes the whole graph up. It defines when this graph runs. For example, when the player walks into a trigger, presses an interact button, or attacks an object. There are a few main types of nodes you will see in the node library. Event nodes, mentioned earlier. Execution nodes, actions that change the game, like moving entities, playing effects, or spawning objects. Flow control nodes, things like branches that decide which path to follow. Query nodes, they ask questions like, which player is this? What is this variable's value? Or where is this entity? Operation nodes, math and logic helpers, like add, subtract, compare, and so on. There are two types of connections between nodes. The white lines are the execution flow. They show the order things happen in. You can read them like a sentence from left to right. start at the event on the left, then follow the white line through each action. The blue lines carry data, things like numbers, entities or variables, from one node to another. Those lines don't control the order, they just pass information so each node has the values it needs. Let's create the first node graph under the Entity Node Graph tab. Every node graph in this guide will be created there. Right-click on an empty space and choose Create Node Graph. You can rename it to Silly Motion. All these steps we took earlier, adding collision trigger component, adding custom variable called pathWaypoint, and adding a path with its unique index, will now help us in making our Seelie move to the next waypoint properly. This is a simple node graph that starts with the event node when entering collision trigger, connected with an executive pin, the big white connection, to the execution node Activate Fixed Point Motion Device. Target entity could be taken both from entering entity and trigger entity, but entering entity is the entity that enters the trigger area, and that would be the player, and we want the motion to be activated on Seelie, so connect trigger entity to target entity. I mentioned earlier that the motion device name will be needed for node graphs, and if you named your movement the same as I did, type Seelie Motion here. Set the movement mode to uniform linear motion, speed to 5, and parameter type to fixed speed. Movement time is not really relevant in this case, but let's set it to 5. Target location and rotation is taken from query node getSpecifiedWaypointInfo. You need to paste here the index of the path you created earlier. PathWaypoint ID will always be taken from query node getCustomVariable, also connected to trigger entity. Variable name here has to be the same as you chose before. If you followed my guide, it's pathWaypoint. Next, we need to create a simple addition so that every time we enter Seelie's collision trigger, the variable gets bigger by 1, and in result, pathWaypoint ID always sends the location and rotation of the next waypoint. Simply create an addition node and connect it to variable value in getCustomVariable, and on the bottom type 1. Then connect result of that operation to variable value in execution node setCustomVariable. Then connect trigger entity to target entity in setCustomVariable, type the same variable name as before, and connect the executive pin from Activate Fixed Point Motion Device to setCustomVariable so that both of these nodes trigger roughly at the same time. Then we can make a second part of this node graph, something that disables the collision trigger on our Seelie once it reaches the end. All we need is an event node when custom variable changes, double branch, and activate disable collision trigger node. Connect getCustomVariable to equal node and result to condition in double branch. In my case, I check if the variable is equal to 5, since at that point the Seelie will be sitting at its court. But if you created more waypoints, you will need to adjust accordingly, since the variable value starts at 1 and increases by 1 every time the collision is triggered and Seelie moves to a new location. That's pretty much it for this node graph. Remember to mount this node graph on your Seelie by going into the fourth tab and clicking on Add Node Graph. Next, we need to create node graph responsible for spawning our reward after Seelie reaches its court. Once again, we need to use the when entering collision trigger event node and connect the executive pin to the double branch node. The purpose of this is to check whether the entering entity is indeed the Seelie, since we don't want anything else, like players or creations, to trigger this. To do this, we can use query nodes like getAllEntities on the field, connected to getEntityList by specified prefab ID, where prefab ID is the ID of our previously made Seelie in prefab library. Since we only have one Seelie on the field, we can just use the getCorrespondingValue from list node and take the first value from that list. Note that the corresponding value from list node starts counting from 0, so to query the first entity in a list, you need to type 0 under ID. Then we use the equal node to check whether the entering entity matches Seelies prefab ID, and if that's the case, then double branch will resolve to yes, and from there we can continue creating the node graph. Now we just need two separate create entity nodes to create our chest and pile of Mora, and if you haven't already placed them somewhere in your stage, now is the time to do so, because we will need to copy their GUID. GUID is different from prefab ID, since every newly placed object will have different GUID. Optionally, you can add some VFX to the chord to make it look better when Seelie reaches it. You can do that by creating another node called Mount Looping Special Effect and selecting Special Effects asset from the list. I chose 11, which is Cyan Ascending Airflow. If you're not sure about the attachment point name, most objects should have GI root node point available. You can check preset attachment points in the Model tab. You can also create your custom attachment points by adding that component. I chose a slight offset in the y-axis to make the VFX play a little higher from the ground. You can also choose whether to play the built-in sound effect for your chosen VFX. Remember that your target entity for this is the trigger entity. After you're done, save your node graph and mount it on your Seelie chord. We're pretty much done, we just need one last easy node graph to make our chest openable. Since we only have one option in our tab component, we don't need to check which option the player chose when he interacted with our chest. We can just connect event node when tab is selected straight to set preset status, where preset status index is taken from the model tab of our precious chest, and set the value to 1 this time. As shown before, value 1 in this case means that the chest opens. Then we just need to disable the tab component, since we already opened the chest and no longer need to see the prompt. Simply connect activate disable tab node to set preset status, or just straight to when tab is selected, set the tab ID to 1 and set activate to no. Then save the node graph and mount it on your chest. That's it. You have now created a fully functioning Seelie that you can follow around, and you get rewarded once it reaches its chord. Next, we will create a cube device puzzle from Inazuma. The rules are simple. Each cube has one special purple side. When you attack the cube, it rotates 90 degrees clockwise. Some cubes only rotate themselves, while others also rotate adjacent cubes when hit. The goal is to make all cubes face forward with their purple side. Let's go back to the prefab library and build them step by step. As before, we'll do everything we can in the prefab library before moving on to node graphs. Start by selecting a model for the cube, for example a stone cube. To create its special side, use a decoration. You can access decorations by selecting the decoration editor under the Model tab. For example, use an electrocube decoration, flatten it by setting its X zoom value to 0.01 and make it a bit larger with Y and Z zoom values of 2. Also disable its native collision. Next, add a unit tag to the cube, which we'll use later in node graphs. Click Add Unit Tags, then open Unit Tags Management tool and then create new unit tag. Name it however you like, the index number is more important here. In this guide, the tag is named cube. For the first time, we need to change something in the second tab. For an object to register being attacked, it needs a hard box. Click Advanced Editing under Hard Box, click plus, set it to initially effective, and try to match the cube's shape with the trigger area shape. For example, choose a cuboid with zoom multipliers of 3. In the same tab, make the cube invincible, otherwise it would eventually be destroyed by attacks. Next, add a custom variable to the prefab. Click Advanced Editing under Custom Variable and click Add New Variables. In this guide, we'll name it CubeState to keep things consistent. This variable tracks which side is currently facing forward. 1 means the cube faces the correct direction, 2 means it's rotated 90 degrees clockwise, 3 means it's rotated 180 degrees, and 0 means it's rotated 90 degrees counterclockwise. Set the type to integer and the initial value to 1. Now, add one more component, basic motion device. Click Advanced Editing, then plus. Do not set it to initially effective. Change motion type to uniform rotational motion. The key option here is the relative rotation axis orientation. Set Y to 90 so the cube rotates 90 degrees clockwise each time it's attacked. For a quick rotation, set effective duration to 1 second and angular velocity to 90. That way, a full 90-degree rotation takes 1 second. For a slower rotation, for example, use 2 seconds and an angular velocity of 45. Remember to name this basic motion. In this guide, it's Rotate 90 CW. For cubes that start in other orientations, create copies of this cube with different cube state values. For example, copy the cube, rotate it 90 degrees, and set cube state to 2. Then copy again, rotate 180 degrees, and set cube state to 3. This guide uses only these 3 variants, but you could add the 4th if you ever need it. First node graph we have to make is the one telling our cubes to rotate 90 degrees clockwise every time their cube state variable changes. We can do it by utilizing the event node when custom variable changes and execution node activate basic motion device. In between them, we just need to check whether the variable name is indeed cube state. We can do that by connecting variable name to input 1 in equal node and typing cube state in input 2. Connect result to double branch and it will resolve to yes every time that happens. If you followed my guide, then the motion device name will be Rotate 90 CW, otherwise input your device name here. Next, we need to make a node graph that resets the value of the cube state variable to 0 after 3, since our cubes have only 4 sides, and other values than 0, 1, 2, and 3 would not be valid. Again, we can make use of the when custom variable changes node, this time connected to get custom variable node, and then to equal node with input 2 set to 4, since we only want this node graph to trigger once cube state has a value of 4. We then need to connect double branch to set custom variable node, enter its name, and connect target entity to event source entity, and what's more important, connect subtraction node to variable value. What this does is basically every time the cube state value gets to 4, it subtracts 4 from its value, resulting in a value of 0. Both this and the previous node graphs have to be mounted on every single cube prefab you've made. Next step is creating 2 more node graphs, one for the cube that will rotate only by itself, and one for the cubes that will also rotate adjacent cubes. Let's start with the single rotation first. This and the next node graphs have 2 parts, because they also contain the part for the win condition, but let's focus on the basics first. Let's start by creating when attacked node and connecting it to double branch, with condition being that the cube is attacked by a player, not objects or creations. To do that, we can use query node query entity function and connect it to attacker entity from one side and input 1 in equal on the other side. You can check functions in the main menu, stage settings. As you can see, the player function has an ID of 1, so that's what we need to put in input 2 in equal node. Then, just like we did with subtraction in the previous node graph, we need to do the exact same with addition node this time. Basically, we want to add 1 to the cube state value every time the cube is attacked, and as we saw in the previous node graph, this will cause a 90 degrees rotation on the cube. The second part of this graph is the win condition part. Its purpose is to constantly check whether the win condition, meaning all cubes facing the correct way, has been achieved, and if it has, create a reward. First, create a getEntityList by unit tag node and paste the cube unit tag we added earlier. Then for every existing cube, create a set of nodes. Get corresponding value from list, connected to getCustomVariable, connected to equal with input 2 value of 1, and then result connected to double branch. Remember that getCorrespondingValue from list node starts counting from 0, so if you have 4 cubes, your last node will have ID of 3. This set of nodes checks the value of each cube on the field, and their corresponding double branch node resolves to yes only if the value is currently 1, meaning that the cube is currently facing the correct way. If you wanted to create puzzle with, for example, 6 cubes, you would have to create another 2 rows of the same nodes, with the last ID in the getCorrespondingValue from list node being 5. Then at the last double branch, we need to create some kind of reward. I did the same thing as in the Seelies part. Created an openable chest filled with Mora as well as some fireworks this time. I will show you how to create them a bit later. If you wanted your player to automatically win the stage after completing the puzzle, you can use the setPlayerSettlement_Success status node and set it to victory, then connect that node to settle stage. Player entity can be taken from multiple sources. You could even connect attacker entity from when attacked to it, since only the player can attack the cube. Otherwise, you can use query node get all entities on the field, then shrink that list by connecting to the getEntityList by specified function, and again typing function ID as 1. And since we're the only player on the field, we can use the getCorrespondingValue from list, take the first value, and connect that to setPlayerSettlement_Success status. Mount that node graph on the cube you want to rotate only by themselves when attacked. In my case, it's the first cube, cube A. Then we need to create the node graph that will also cause adjacent cubes to rotate. Some of the process will be the same, for example the whole second part, but it will be a little more difficult. The first 4 nodes will be identical, so feel free to copy the when attacked, double branch, query entity function, and equal nodes. Then we need to create few nodes that tell our attacked cube to also look in a set radius around it and influence other cubes around it. Start by creating a getEntityLocation and rotation node. Rotation is not relevant here, but attacked cube's location needs to be connected to center point in getEntityList by specified range, and the list will be looking for cubes is taken from getEntityList by unit tag node, since every cube has the same unit tag. The radius is a very important setting here because it influences how close the cubes have to be to each other in order for the puzzle to work. I set the radius to 5 and placed my cubes around every 3 meters so that the cube in the middle can only influence 2 adjacent cubes and not the cubes farther away than that. With that in mind, there are only 2 possible outcomes here. Cubes in the middle will influence themselves and 2 adjacent cubes, so 3 in total, and leftmost or rightmost cubes will influence themselves and 1 adjacent cube, so 2 in total. These 2 options are reflected here by creating 2 double branches, where condition is connected to equal node taken from getListLength node. In one equal node, the input 2 is 2, and in the other it's 3. Only one of these double branches will result in yes at any given time, since it's not possible for the list length to be 2 and 3 at the same time. This step is probably not mandatory this time, but it's a good practice to check the list length, since query nodes like getCorrespondingValue from list may cause your node graphs to throw errors when they can't get a correct ID from the list. They would output the value as 0, and that may cause your objects or creations to behave not like you wanted them to. If you haven't already, create 3 previously mentioned nodes, get corresponding value from list, and set their ID to 0, 1, and 2 respectively. This part is also important. If you want your cube to influence more than 2 other cubes, you will also need more of these nodes here. Now let's look at the part where cubes can only influence one other cube. That means they are placed at the far left or far right. Fortunately for each option, we just need to copy and paste the same 3 nodes enough times. Get custom variable, set custom variable, and addition with a value of 1. Just like we did with the single rotating cube, we want to add 1 to the value of cube state variable to every cube we want to rotate. In the first case, we need to paste these nodes 2 times, and in the second case 3 times. All of these nodes will be the same, except for one big difference: target entity in both get custom variable and set custom variable. In the case of 2 cubes, we need to take the target entity from the first and second get corresponding value from list nodes. In the case of 3 cubes, we need to take the target entity from first, second, and third nodes. At the end of both cases, we need to have connection to the second part that is identical to the same part from the previous node graph. Feel free to copy it. We need to have 2 connections this time because, as I mentioned before, only one of these cases will be active at any given time, never 2. Now, it's time to place our cubes and chest with Mora in the Entity Placement tab. I suggest rounding the numbers in the location coordinates so it's easier to count the distance between cubes. My puzzle consists of 1 cube A, 2 cube Bs, and 1 cube C. As I mentioned before, I place my cubes every 3 meters. As before, copy the GUID of chest and Mora pile and paste them into the create entity nodes. Finally, head back to the prefab library to create simple fireworks launchers. Create an empty model and disable its native collision. Place these where you want fireworks to spawn after finishing the puzzle. For each object, create a play timed events node and a query entity by GUID node. Copy their GUIDs into the correct places and connect the entity output to target entity. Select Pyro Fireworks in Special Effects asset, use GUI root node as the attachment point name, and enable Play built-in sound effects. Adjust any other options you like. After finishing the puzzle, you will see an openable chest and some fireworks as a reward. To declare the player victorious and settle the stage, you have several options. First, you can connect the previously mentioned nodes called Set Player Settlement Success Status and Settle Stage to the end of the cube puzzle node graph. This will automatically show the victory screen as soon as the puzzle is solved. Alternatively, you can create another interactable object that settles the stage upon interaction, and that's what we'll do now. Hidden behind the shrine will be a magic lever that declares us victorious even if we don't solve the puzzle. To make it, head back to the prefab library and look for the wooden lever mechanism model. Just like the chest, it has a preset status that we can reuse in node graph. The only component our lever needs is tab. Name the option Settle Stage and adjust its trigger area a bit so it's easier to interact with. Now it's time to create one last node graph for our lever. As mentioned before, we ideally need 2 nodes to settle the stage. One called Settlement Success Status, which declares either victory or defeat, and another one called Settle Stage, which actually completes the stage. We want this to happen after we interact with the lever, so the starting event node will be when tab is selected. We can also add the set preset status node, where the preset status index is taken from the model tab of our lever. In practice, you won't really see the lever move because the stage settlement happens so quickly, but this is a good practice and something useful to remember for future stages. We can safely connect selector entity to the character entity in getPlayerEntity to which the character belongs, since selector entity is the one interacting with the object, and in this case, that will be the player. Then connect affiliated player entity to player entity in set player settlement success status. However, the target entity in set preset status needs to be connected to event source entity because that represents our lever. Once you're done, save your node graph and mount it on the lever, then place the lever behind the shrine so only the most observant players will find it. After you're done, we just need to do one last thing to fully replicate this tutorial stage, and that is setting the background music, or BGM. Click on the main menu in the upper left corner and look for Manage Background Music tab. Then click on Select Background Music Asset. You will be able to choose from many soundtracks, some of which you may be familiar with from Genshin Impact. I chose Cheerful March. You can also tweak volume and playback speed here, as well as enable or disable fade in, out, and loop playback. You may also select effective time range of your chosen BGM if you don't want to play the whole track. And that's it for this tutorial. We've gone from importing the scene, through building a Seelie with its path and reward, all the way to cube device puzzle with a win condition and fireworks. Remember, you can tweak any of these setups to fit your own ideas. Different paths, different rewards, or more complex cube layouts. You will find the assets and stage GUID in the description if you want to open this exact setup and play around with it. Thanks for watching, and see you in the next guide.